Moi or good afternoon. Pekka Leppänen from IBM Finland, working with healthcare. I'd like to do about two things in the next 8 to 10 minutes. Take another use case, what we've done with HUS regarding sepsis, and then we'd like to work with you and proposal on how to go forward. Let's go to HUS sepsis case, which I would define as advanced analytics. Sepsis or serious infections with neonatal babies is extremely dangerous. It's often lethal, and even when the babies survive, it may leave lifelong serious problems. So for this reason, in acute care, extensive care, the neonatal babies are thoroughly monitored. That's been going on for years. The problem is that despite of all of the care and monitoring, when you follow individual signals and get to the trigger level of an alert, things are serious. Things are going wrong and everything is urgent. And there are multiple signals. Oops, didn't want to do that. There are multiple signals. It's not possible humanly to correlate. Signals are vague. They are complex. So what we've done is, with the clinicians, physicians at HUS, is to use machine learning together with clinical expertise, based on history data, create machine learning models which can predict the occurrence of sepsis. And what's been achieved is that in 90% of the cases, the problem can be identified 24 hours in advance. And obviously, that early, things are not urgent, and there's time consider to do the right things early enough. The flow for the approach is a classical big data analytics. So for years, the data has been gathered, and there's an abundance of data which was available for the data scientists and physicians to work upon together. That was available in a database, and in principle what was done is that, say that we have 3 years of data, use 2 first years of the data to create predictive models between data scientists and physicians, and test everything towards the last year. And through interactive, iterative process, the model was trained with the existing data, and then when we have a model we are comfortable with, a model where we can get the 90% accuracy 24 hours in advance, then what we can do, we can apply the results of that model in real time, reading all of the data feeds for each neonatal baby, and making the assessment, risk scoring, in a matter of seconds, and then communicating that to the care team. And with this, we get to a point where really serious situation is identified early enough, and there's plenty of time to analyze the situation deeper and to do the proper actions. This is also a classical way of applying analytics in huge number of different cases. Collect the history data, create models, leave some of the data for testing, keep on repeating until you are comfortable with the test data set. And then when you're done, you can push the results for real-time analytics and operate this even in real time. So continuing with what Grant said is that as we get more and more information, and less of the information is neat numbers in columns, we need to get to a point where systems understand the problem at hand in the way humans do, so that they can read, understand natural language, and then what they do is reasoning, create hypotheses, multiple hypotheses, maybe tens, hundreds, rank each hypothesis, and present maybe the top 3, top 5 to people in care of the patient, and also tell the justification. Why is this rank so high? So that the person in charge has best possible information for decisions. And every decision, every outcome for sepsis, for Watson, is stored. So as you use the system, it gradually gets better. Every time there's a correct answer that enforces the model, sometimes the answer is not correct. In sepsis, we are 90% correct. If it's in the 10% area, that's also fed back. And every time the model gets better. So there's a great opportunity for data scientists and clinicians, physicians working together. And it's been, I believe, a very positive experience, both sides at HUS. And if you want to know more, please contact me or Mika, who was here early in the panel. Or if you're in the technical side, it's easy to test things out. You can go to the Bluemix, and the data scientist tools are available there. Or if you want to see Watson, there's a link to the Watson. Either way, we'd be happy to work with you. Thank you.